So, today we want to talk about standard deviation. We've talked about measures of central tendency, mean, median, mode, and we really want to start talking about range of data. Where can data fit? We talked about outliers the other day. Those are kind of things that fall outside of the norm. Standard deviation and all of the measures of variancy are just talking about how do the data points relate to each other and how do they relate to the mean, and kind of a way to measure data. So today we're going to talk about measures of variation. How does the data spread out? What is a way to describe how the data spreads out? And the easiest forms of this is the range. And you've done range before. Range is when you take the biggest data set value in the data set, subtract the smallest value in the data set, and that's the whole range. But when you have outliers, the range may not always be the best measure, because if you have one really large outlier, one really small outlier, that's making the range a lot bigger than actually most of the data goes in. So it's just one measure of variation. Another measure of variation is actually the interquartile range. We discussed when we did the box and whisker plots, quartile 1 and quartile 3, they're kind of the medians of the medians. And what's interesting about that is because the quartiles are the halfway point of those two halves of the data, half the data actually falls between those two quartiles. So the ones that are falling outside of those two quartiles are kind of the outliers. They're the ones that lie the most out. So half of the data that's outside of the middle. And so the interquartile range really just gives you only the numbers that are in the middle, closest to the mean. If you think about it, they're the things that are actually inside the box in the box and whisker plot. The minimum and the maximum give you those outliers, those that are the farthest out. And so those are kind of the whiskers of the box and whisker plot. But the interquartile range is just the box part of the box and whisker plot. And half the data does fall within that box. So sometimes we use it to really look more at what is the central part of the data and not just these outliers in the range. And so they're another option for measuring variation. But the one we really want to focus on today is standard deviation. And how do we find it? What does it tell us? That kind of a thing. So let's take a look at standard deviation. Standard deviation is a process. It is not short, and I won't say it's simple either. However, if you're organized in how that you do it, it can be simple. If we take a look at the steps, first step is to find the mean. We know how to do that. You did it all day the other day. Find the mean of a data set. Once you find that mean, then you're going to have to take every value in the data set and subtract the mean from it. Because standard deviation is actually measuring how far is the data from the mean. We're using that center, that mean, and measuring everything from it. How far away from that center is the data point? So we have to go through every single data point and subtract the mean. After we do that subtracting, then we have to square all of those differences, all those distances from the mean. Square all of them. That gives us a whole new list of data. Now that we have that whole new list of squares, we're going to take that list and we're going to find the average of that list. And once we have the average of that list, then we take the square root to actually find the standard deviation. So it is a 5-step process. This is not a, hey, let me jump straight to a formula, plug a number in, boom, I've got the standard deviation. Standard deviation is a process, all right? So you want to make sure that you follow that process. Let's take a look at a problem. All right, find the standard deviation. So we're going to start with a fairly short list because we don't want to take all day just to learn how to do this. For your project, obviously, you've got a much larger list, and so we'll talk about later some things we can use to do that. Your calculator, programs on the computer like Excel, these kind of things, you can use them to do the math, especially when you're using a large group of numbers. But let's just talk about the process for standard deviation. Standard deviation, I've got 5 numbers. I've got to find the average. I can't move on until I find the average. So if I type all those in my calculator, 48, 53.2, 52.3, 46.6, and 49.9, go to the list, choose mean, find the mean. I find out that the mean is actually 50. Our average is 50. So I'm being organized. So I'm making a chart. So I've got my original values in the first column, and now I have my mean in the second column. I need to subtract. That was the second step. Second step was to subtract these. So 48 minus 50, negative 2. Negatives, keep them. It matters. 53.2 minus 50, 52.3 minus 50, 46.6 minus 50, 49.9 minus 50. So I just subtracted everything, got another column, keeping it organized. Right? So I've subtracted them. We said our next step after subtracting was to square them. So I've got to take negative 2.0, square it. 3.2, square it. 2.3, square it. So we've got to square all of them. And that's what we do. Very simple. Just square them. All right? And now that I have them squared, we said we had to find the average of that list. So I've got to find the mean again. I've got a calculator. 4.00, 10.24, 5.29, 11.56, 0.01. Type them in. Find the mean. Nope. 6.22. Now, this is where I tend to mess up, because I've done so much work. I've subtracted, I've found averages twice. Usually at this point I'm like, finally, I'm down to one number. Problem is, for standard deviation, you have to take the square root of that average, and you don't want to forget to do that. That's a big deal. It does change the number drastically. So you want to make sure that you actually do take the square root. So when I take the square root, the standard deviation actually is 2.5. Now I want you to pay attention to the symbol. This is a lowercase sigma. A lot of you are used to the big sigma, but this is the lowercase sigma, and that is the general abbreviation symbol that we use to stand for standard deviation. Up at the top, you notice the X with the bar over it. X stands for a value in the data set. X with a bar over it stands for the mean of that data set. And you may even actually see that on your calculator. They use those symbols on your calculator. And so you want to get used to those symbols. X bar is the mean, and the sigma is the standard deviation. And those are our symbols for that. So what do we use standard deviation for? All right, again, standard deviation is a measure from the mean, from the center. And usually what we use standard deviation for, once we find it, is to take our data and kind of set it up into groups. We start from the center. We start from the mean. And then we measure out by one standard deviation in either direction. So in this case, the standard deviation was 2.5. Our mean was 50. So if I add 2.5 to that, I get 52.5. And if I subtract 2.5 from that, I get 47.5. And so any data sets or any data points that fall between 47.5 and 52.5 fall within one standard deviation of the mean. We could go out 2 standard deviations. That would be 5 in either direction. So from 45 to 55, that would be all the data points that fall within 2 standard deviations of the mean. And in fact, a large chunk of ours, all of ours, fall within 2 of the mean. And so we kind of talk about data points being within so many standard deviations of the mean. And in fact, we have a name for that. We call that the z-score. A z-score is the number of standard deviations that a value is from the mean. Each value in the data set has a z-score. And you may even hear about this when you talk about testing. You'll hear them talk about z-scores. And so each data set, or in the case of testing, each student, their grade has a z-score. How far were they from the mean? How far were they from the average? Some students are above the average. Some students are below the average. Some kids are the average. But the measure of that is the z-score. And so it's actually a pretty simple little thing to figure out. To find the z-score of any value, we just subtract it from the mean, or subtract the mean from it, and divide it by the standard deviation. That tells us how many standard deviations. Is it 1 standard deviation away? Is it 2 standard deviations away? That kind of thing. An example. A set of values has a mean of 85 and a standard deviation of 6. Find the z-score of the value of 76. So I'm going to take 76. I'm going to subtract the mean, which was 85. So that's going to give me a negative. 76 minus 85, and then I have to divide it by the standard deviation, which is 6, and it gives me negative 1.5. And that makes sense. 76 was below the average, so it makes sense that it would have a negative z-score. If it was above the average, it would have a positive z-score. But that tells me that 76 is 1.5 standard deviations away from the mean. So they're not right next to the mean. They're kind of down in the lower set. And so these are z-scores. And so this is what you need to know in order to do standard deviation.